Hey everyone, welcome back to my YouTube channel. I've been spending some time with ThreeJS recently. It's a JavaScript library used to create and display animated 3D graphics in a web browser using WebGL. In this video, we'll be getting a hands-on with ThreeJS and we'll create an interactive globe which looks like this. That looks neat, right? Let's make the world go round using JavaScript. I have a very basic setup here. There's the HTML file which has a style.css link to it. And to start with ThreeJS, the first thing that I'm going to need is the ThreeJS library. So I'll head over to Google, search for ThreeJS, head over to its official website, threejs.org. From here, I can get the ThreeJS library. So let me just copy this and put it on my local. We can also use it as a CDN, but I'm just putting it here in my local machine. Once we have that, I just want to add that script. And I also have a main.js created here where we'll be writing our custom code. Currently there's just a console log written there. So let me include that too. Okay, let's go over to our browser and I'll now serve this HTML using live server. So if we head over to the console, this is coming from main.js, and to check if ThreeJS is loaded properly or not, we can just type 3 here and we can see it is defined here in our window. So that means ThreeJS is loaded in our web app. I'll now go ahead and create a canvas, give it an ID, globe. Okay, add a little styling to our globe canvas. I'm just fixing it to the top left. Okay, we don't see anything right now. Now we'll go ahead and start adding some JavaScript using the ThreeJS library to paint 3D objects in our canvas. I'll go ahead and create the main function where we'll be defining our ThreeJS scene. So let's go over and have a quick look at the main components of any ThreeJS scene. So for any scene, the main thing that you need is a camera and then light. And in terms of code, we'll be needing lights, camera, and a renderer. So let's start by defining that. So I create a main function here. In which I'll first create a scene. And then a renderer. Just copy that definition. In the renderer, I'll be using the canvas, which we defined here in our HTML with the ID globe. I'll give this renderer a size which is the same as my window's width and height, so that it covers the whole screen. Once the renderer is in place, the next thing that we need is a camera. So I'll just add a perspective camera here, which is again provided to us by ThreeJS. So let's add a camera here. So camera takes these parameters: field of view, the aspect, and where do you want to place it. And then I'll just define a render function in which I'll call renderer.render the scene with the camera. So now when we go back to our page, let's define it as a function and let's call it onload. Okay, we don't see anything yet because render is never called. So let's call render. Okay, now we get a black canvas, which is some progress. Let's go ahead and try to add some 3D object into the canvas. So I'll go ahead and start with the earth geometry, which is going to be a normal sphere at its core. So here I create a new sphere. Then I have to add a material to it to give it the texture. For now, I'll just keep it blank and show it as a wireframe. Or I'll just comment this for now. And then I'll create a mesh out of it. And then we can add this mesh to our scene. Okay, even now we see everything is pitch black, and that's because we're missing the lights. There is no light in our scene right now, so everything will be black, irrespective of how many number of objects we put in here. So I'll go ahead and add ambient lighting. So ambient lighting is something that just lights up the whole scene. Let's uncomment this. Okay, we see some lines on the canvas now. And the reason we are not seeing the sphere yet is because of the position of our camera. We have added a camera to the scene, but right now, since we have not defined the position of anything, our 3D object as well as our camera is at the center of our scene. Now, when it comes to 3D painting, we have 3 axes. We are very well familiar with the 2 axes, which is X and Y. And then we have the Z axis, which is for the depth. So I'm going to set the camera's Z position to say 1. Okay. Now we can see we're able to see some part of the sphere forming up. So let me move the camera a little more outward in the Z direction, which is the depth. Okay, so that's our sphere. If I set this wireframe to false, then we kind of see a circle, but we know it's a sphere. But the reason it's looking like a circle to us right now is because there is no light, no animation to it. So let's try to add a point light and see if that will bring out the 3D aspect of this sphere. So I'll add a point light along with the ambient lighting. And set its position and add it to the scene. Okay, now the 3D effect really kicks in. We're able to see a light coming in and then it's distributing on the sphere. Okay. We have most of the pieces in place now. The next thing that I want to do is, for this Earth's material, instead of keeping it a wireframe, I want to add some texture to it. And for that, I have added some images of Earth from this source, which has almost everything that we need to show a 3D Earth. So I went ahead and downloaded these texture maps as well as the bump maps. And that's what I'm going to provide to my code now. So let's set the map to texture and then Earth map. This is the file that we'll be using. So after we've added the texture, we can see it's not reflecting anymore on our canvas. That's because once we add a texture to the scene, it starts treating it as an animation. And for animation to work, we'll have to modify our render function in such a way that we'll have to call it for each paint. And we'll take help of window.requestAnimationFrame function here. So this is a function that tells the browser that we wish to perform an animation, and then it requests the browser to call a specified function to update an animation before the next repaint. And that's exactly what we're going to utilize here. So to wrap it up, I'll create an animate function which will be using the request animation frame method from the browser, and we'll be passing in the animate function to it so that it calls the animate function again and again. And from our animate function, we'll call the render function. And initially, I'll just change it to call animate. Now when we go back to our page, it now starts rendering the texture for us. I'll get rid of the wireframe now. Okay, so we see a sphere with Earth's image on it, and it's wrapped around to the sphere. Along with the texture map, I also have a bump map that I'll be using. Before we talk about how bump map is going to help us, let me try to zoom in a little by positioning my camera. So right now we see that the map texture is flat, and bump map does exactly what it says. It just adds some bumps to it based on the map. So like this image is going to tell how many bumps we need at how many places based on the color. So let's just go ahead and add that. So I add a bump map and a bump scale. And when we come back, now this looks a little bumpy, and it gives a more 3D feel. Now to verify that it's a sphere, let me try to add some dummy rotation to it. And for that, I can simply say during my render, earthmesh dot rotate on world axis, and I'll give it, let's say we want to rotate it on the y-axis with a speed of 0.01. Okay, so now the world is rotating. But we don't want it to rotate indefinitely. We actually want it to rotate as the user drags on the screen. And for that, we'll be writing some helper functions. So I'll just go ahead and create an event on mouse down. So I'll add an event listener. So whenever we'll click on the screen, on document mouse down will be called. And let me take a few more parameters here. For example, this. So I want to know the position of mouse X and Y, and where it was when the user started the mouse down, the window half X and half Y. And I'll also use a rotation variable. Okay, rotation in the X direction, rotation in the Y direction. Now I'll go ahead and define that function on document mouse down. Prevent defaults. And I just want to note the position X and Y on the mouse down. So from the event, I'll get client X and Y, and I'm just subtracting window half X and window half Y from it, so that I know from the center of the screen how far left or right and top and bottom the mouse position is. So that will be saved here. I want to add one more event listener. As soon as the user will click on mouse, we'll add an event listener to the movement of mouse, so that as the user drags, we're able to change the rotation speed and the rotation direction. So as the mouse will move, we'll set the mouse X position from the event and again subtract it from window half X. Same for Y. And now I'll be changing my target rotation factor. And this will be the difference of current mouse X and the mouse X that was at that time when the user clicked and started dragging. And I'll just multiply that with a drag factor, which I'll just define at the top. That is how much speed will get affected as the user starts dragging. Same for Y. Okay, now this looks good. Now let's use this speed when we are rotating our Earth. Similarly for the next axis. Even.prevent defaults is not a function because it's prevent default. Okay, now as I'm moving my mouse, it is affecting the rotation. But the problem is it's not letting go of my mouse right now. So wherever I'm moving my mouse, it's just rotating the globe. So let's go ahead and fix that. I'll add one more event, which will be on mouse up. Mouse up means when I'll release the click, it will remove the event listener from mouse move and also from mouse up, and we'll add it on mouse down itself. Okay, now I can move my mouse freely once I have given a movement direction to the globe. So far so good. Now one more thing that I want to improve here is it's not stopping right now. It's just taking a direction and a speed, and it's just continually moving in that direction. So to fix that, I can add a slowing factor. And as I'm rendering the Earth, I can change the target rotation X and Y by the slowing factor. So now after each render, the speed will become 98% of the initial speed. Okay, something doesn't look right. Yeah, instead of minus, it had to be a multiply. And that makes sense because it will be 98% of it, so we need to multiply. Okay, now when we are landing on the page, it gradually stops, and when I move it, it's acting more natural now. Okay, with that we have almost everything in place. Now I'll just go ahead and add a few more geometrical pieces for the clouds and the stars. So let me just go ahead and do that. It is straightforward. I have an image for cloud. I'll just add that geometry in here. Okay, now I have a cloud surrounding the Earth, but it's not moving right now. So I'll just go ahead and use the same rotation mechanism for the cloud mesh. Okay, now that looks much better. Now to give it a galactic feel, I'll go ahead and add a star mesh, which will be this galaxy. So the size of my Earth geometry was 0.5. For cloud it was 0.52, so that it is just a little bigger than the Earth. I can just tweak that and see how that will look. Okay. So for the star, I just want it to be big. So I've set it to 5 so that it surrounds. It will be a sphere, but it will surround the Earth completely. Okay, few more things to note here. For the cloud, I've set it to be transparent. If I don't do that, I'll have the complete sphere surrounding the Earth, which looks cool, but that's not what we want. So I'll set it to transparent. Similarly, for the star geometry, we are putting it at the back side so that it looks behind the Earth. If we want, we can set rotation for stars also, but that's subjective. But what we have right now is exactly what was shown in the starting of the video. So with 100 lines of code, we have a user-controlled globe using ThreeJS on our screens. I hope you enjoyed creating this globe and getting hands-on with basic concepts of 3D rendering with me. If you have any questions, please put them in the comment section below. If you like the video, please share it with your friends and make sure you subscribe to the channel for more learning content. I'll see you in the next one. Peace out.